welcome. I appreciate everybody staying late on the second day to hang out with us today. My name is Sean DeArmond. I'm a web architect at UC Davis.
And I am Mark Miller. I am Sean's minion at UC Davis.
Thank you, Mark. So we're gonna talk about some continuous integration and automated testing, DevOps-y things. I heard a good line. This is at a presentation at DrupalCon, where DevOps isn't the thing you like go and buy. You can't walk into a shop and say, "Hey, I want to buy some DevOps." It doesn't really work that way. DevOps is more of like a cultural thing. It's something that you just have to, you and your team have to understand and really, believe in to move forward. So that's what we're trying to do now, and sometimes you don't know where to start. And I wish I had a presentation like this when I was trying to figure it out, because that would have helped me a lot, which is why we put this together for you. This is literally a slide from a 2012 presentation at Badcamp. This was sort of the accepted, you want your dev test in live, and then the, files move, or the code moves upstream, and the files and your data move downstream. This isn't necessarily wrong anymore, but I think it needs some refinement. And so this is what I want to show now. And I still don't think this is like, I don't know, this isn't canon or anything like that, but I think that this maybe gives a better idea of all the kind of phases that you go through while going through development and release. And so also we have this stuff, right? So your data still has to flow downstream, but you're not necessarily like going from live to test to dev. Really, it all either comes from live, really, is where it just all comes from. And that data needs to get down into each of these different places. Notice there's no line going to Git, because data doesn't go into Git that way, but your data goes back to these others. And anytime you have an arrow, anytime you see a green arrow here, if you're doing that manually, that's not necessarily bad, but those are all the places that you can find efficiency gains through scripting and automation. You're gonna do some of this manually. You might be doing all of it manually now, and you might have the most efficient process in the world, and you're still gonna do one of those arrows, you'll probably just end up doing manually. And that's not necessarily a bad thing. But I think that the purpose of this, the purpose of everything that we're doing here, is trying to just make this workflow faster, because this is more complex, I think, than it used to be. And with Drupal and modern web development, it just is more complex. I don't think there's any way around that. So we want to try to, as much as we can, script everything that we can, because that just makes you faster. If you have to do all those things manually and it takes you a week to do a whole deployment because you have to do all those things manually, come on, we got to be able to figure this stuff out. So what I'm going to do is I'm going to look at each of those steps. We're going to go through it. We're going to spend a lot of time on automated testing, because I think there's a lot of good gains there. But let's look at each of those things and what are the things that we can do to make things more efficient. And so starting with local development, there's so many great tools for local development now. I mean, history will show, but I think we're sort of living in a golden age of local development tools right now, with Docker, what we have now. And so if you're still using MAMP, or you're using some sort of local install that's, I think it's time to move on. There's some really great stuff here. We use Doxel, but really a lot of these are similar. So I think that's great. Certainly if you're doing more traditional installations using something like, even like Ansible or what's that other one that I forget. Anyway, try to do this stuff, because you can script a lot of things within your code base here. And so the way that certainly Lando and Doxel and the way these work is that the configuration and scripting of this actually lives in your code base. Like, so for Doxel, there's a .doxel folder, and it contains all the configuration for your local environment, which means that when that project is shared then to your other teammates, you're all running the same configuration. And then you can put scripts in there too. So being able to run a script to initialize the environment, how fast does it take for someone to actually get onboarded with your project? You gotta configure all the stuff, and get your IDE set up right, and you gotta bring in the data. So can you refresh data from live? Well, there's a way to script that, right? There's getting your database, getting your data, bringing that over from live, and if it's just a simple command and it just takes a minute, then that's way better than like logging into the server and getting the database export and then copying the file over and then pushing, the import thing there and then getting the file. Anyway, there's a lot of things that you can do. Also running automated tests and other things. Have a good IDE, that sort of stuff. And so doing that kind of stuff really makes you very efficient in local development. Also, I mean, I shouldn't even need a slide for this, but we all use Git, right? And so use Git. You got to. But also, there's a lot of great tools within like a hosted Git environment. Like I don't know many people that just run their own pure Git server. Usually use some sort of service, even if it's locally hosted. And GitLab, Bitbucket, GitHub, they all have a lot of really good tooling around their services that can help with this process too. Things like pull requests, comments within, diff tools, all that kind of stuff. Sometimes you use issues and all that kind of stuff. So being able to use these tools, they often have either their own or they work really well with other CI tools. So Bitbucket has a pipelines, we call Bitbucket Pipelines, and GitLab comes with their own GitLab CI/CD. GitHub tends to work with a lot of different stuff. I don't know if they have anything built in, but they tend to work with a lot of stuff, CircleCI or Travis or anything. So there's a lot of tools around working directly with these Git repos. I also think it's really useful to have a branching strategy for your team. Now this is Git flow, and it's out there, and that's not bad. That's one that you want to use. But there's some other things that you can do within Git that just, from a security point of view, I think is a good idea. You can lock some of your branches, like master and dev, so that it can only be pushed through, say, a pull request merge. So anybody see the article about that Git ransomware that came out a couple weeks ago? We got hit with that, right? And if we had locks on our master, they wouldn't have been able to do that. They wouldn't have been able to push directly to master. If we were using the SSH keys in that situation, they wouldn't have been able to do it either, because they wouldn't have been able to steal our password. But in any case, yeah, using SSH keys, obviously, multi-factor stuff like that. That's not so much an efficiency, but in a sense. I'm getting somebody through. Oh. There we go. We got somebody from the online, and they were making noise, so I needed to close that. Sorry. Okay. There we go. Yeah. So pull requests are a good time to do code reviews and automated testing. This is just one of the tools that you can use within all of these Git environments. Being able to see when people approve, we sort of have an internal policy where, you don't merge until you get an approval from one other person, at least one other person in the team. So being able to see that right within, this is Bitbucket, but they all work the same way. Also having a comment thread is a good idea. Keep this. And then right here, there's the special sauce right there. So there's the integration with whatever CI tool that you're using. In this case, this is Provo. But being able to see all within your pull request that stuff is, that things are good, before you do that merge. So here's some of the CI stuff. This is CircleCI. They all work in a very similar way, but this is, you can see tasks that are being run. This is Provo, which we like, and it's a similar thing where you can see all the tasks that are being done. That's sort of small. I don't know if you can see it, but these are all the tasks that are being done, running automated tests and building the environment and stuff. What I really like about Provo is this thing, view site, because it's actually persistent. It'll run all your tests on the environment, but then it'll actually keep the environment alive for a while. And so this allows people that are non-coders to be able to go and sort of do some, I don't know about full UAT, but at least being able to test the feature that you're building in an environment that's hosted. So it's not like you just run it locally. That one?
Yeah. So, like, do you, like, when people do, like, requests, do you ask everybody to just follow some rules, like documentation, like checking, request, checking with documentation?
So let me make sure I understand your question. Your question is, when we do the pull request and there's a code review, are we doing all aspects of the feature, including documentation and other pieces as well? I also need to speak it again because the recording may not have heard you. Okay, so the answer to that is not necessarily, but we certainly do things when we do a pull request like, does this need a test? You know, so that's one of the things we'll look at. Do we need to write another Behat test so that this new feature that you've created, you know, so we want to make sure it has a test. Documentation, not so much, because we go through a deployment where we actually, not that the deployment takes a long time, but we put a lot of stuff into a test environment for UAT, and that gives us an opportunity to write all of the documentation. So we don't necessarily write the documentation at the same time that we're doing the coding. How do we make sure everything is being documented? So at the end of a sprint, we see the list of all the features that have been added as part of that sprint. And so our support analyst goes through and looks at all of the features that have been completed, and they know they can work on that documentation. Some of it they'll start earlier, you know, just to start putting it together. But we don't make documentation a requirement for the pull request. No. Yeah, go ahead.
So, sometimes we require inline documentation, like
Right.
if you're reviewing code and you can't understand it, we need to put in some inline comments. Oftentimes we'll say you have to do that.
Yeah, yeah, that's true. Thanks. Okay. I think that's where we were. Yeah, so Provo, it actually creates a persistent environment. I also heard that Tugboat from Lullabot does the same thing, which is awesome. I didn't know that, and that's something I might be looking at as well. And these all work more or less the same way. You put together a YAML file, and you tell it what you want it to do, generally in the form of bash or command line commands. Some of them let you attach separate like bash scripts to it, and they'll just run the bash script instead of doing it in line, or they'll do it in line as well. Some of them have plugins, like Provo has this, where is it there? Yeah, the very bottom one there, you can't really see it, but there is a Drupal plugin for Provo, so all I have to say is Drupal version 8, subdirectory doc-root, run install true, profile name, site farm, and it just knows it's Drupal, so it sets it all up for me. I don't have to worry too much about, it runs the Drush site install and does all the things that it needs to in order to make it a Drupal environment, which is just convenient. They have plugins like that. All right, so we're going to dig real deep into automated testing here. My colleague Mark is going to do that. Robots are really good at automated testing.
So quick show of hands, how many of you have done automated testing before? I'm assuming a lot of us, most of us? Okay, cool. Then I'll maybe skip some of the more mundane stuff here, but unit tests. This is the starting point. I guess the simplest example of a unit test is if I said, I'm giving you the numbers 2 and 3, I'm expecting you to give me back 5. That's all I want to know. I don't care how you came to that conclusion. I don't care what you ate for breakfast. I just want to know that this is what I'm expecting you're going to give back. So a unit test is great when you have things like APIs that you're writing for the public, that you're wanting to make sure that if I'm giving you some data, I'm getting the correct kind of data back. The great thing about these is they are super fast to run. So you can have 1 billion unit tests and they can get cranked out lightning fast. The downside is sometimes they're not so easy to write if you're in, for example, Drupal. Sometimes you end up mocking out a bunch of things, because if you just want to test one thing, you don't want to test all these other things. I just want to test this one thing. And sometimes you have all these dependencies on all these other things. And so it can become a bit of a pain trying to mock all these things out. So on one hand, unit tests are great. If you're writing your custom library, they can be really fast to write. If you're trying to write unit tests in Drupal, sometimes not so fast. It kind of depends. And unit tests are generally written in whatever language you're programming in. So PHP, you're probably writing PHPUnit. If you're doing JavaScript, there's about 1,000 unit test suites for JavaScript. These days, we've been doing mainly Jest, but there's a bunch out there, Mocha and a whole slew of others. I assume most of you kind of know the gist of what unit tests are. So quick case study. We recently did a project where we had an API, and I use that term loosely. There's an API that we needed to pull out tons of data and then import it into Drupal. And the way we ended up doing this was using AWS Lambda functions and their step functions and a whole slew of this microarchitecture to massage all this data and then pump it into Drupal with JSON API. Turned out that we had, I don't know, probably a couple hundred Lambda functions. So if you don't know what those are, it's just a very thin function that ideally does a very simple task and returns you a result, or something along those lines. Once you have a lot of these things, it's really difficult to figure out where you're at, what things are firing off other things. So then in AWS, they have these other things called step functions, where you can have Lambda functions triggered in order, and then you're trying to figure out what's being passed from one thing to another. So rather than writing a bunch of code into each of these Lambda functions, the smart thing to do, like most software development, is you create libraries, you create packages. So we had a slew of these JavaScript packages, these libraries, that each of the Lambda functions would call to do certain things, whether it was to get files out of an S3 bucket, whether it was to make API calls to Drupal or this other API. All those things are written in the packages, and then the Lambda function just has to query those public APIs from those packages. So these are perfect use cases for writing unit tests. We want to know that if I hit this function from this package, it's going to do X, Y, Z. I don't care about anything else. I just want to know that's going to work. So in this case, a unit test is perfect. The downside of unit tests is you can get into issues where it works, but things don't work well together. I love this animation because it's two things that work really great, a sliding door and a lock, but together they don't work well. And so this is where integration tests come in. The integration test is just making sure that your stuff works together. So these generally are going to be slower than a unit test, but they're still going to be faster than end-to-end tests, which we'll get to in a few minutes. Integration tests can be a little bit more complicated to write in the sense that now you have to make sure things are going to work together. So in the case of our Lambda functions, when we started getting into that, we said, well, how do we write integration tests for these? And we kind of said, I don't know, because I'm sort of new to the whole AWS architecture. And we figured out this sort of hacky way to run all of our different functions next to each other and then make sure things are passed along. But in the end, it was still kind of hacky. So in real life, we tend to write, at least the stuff we do, doing mainly website development with things like Drupal, we tend to see this. In the ideals, every testing presentation I've ever seen, you have the test pyramid. You have unit tests at the bottom. Those are your fast ones. Most of your tests should be unit tests. Then you have some integration tests, make sure some of those pieces work together. And then at the very top, you have just a couple sprinkles of end-to-end tests to make sure that the whole system works. In reality, for the majority of what we're writing, it tends to look more like this on the right, where we have a couple unit tests because Drupal is doing a lot of what we already need to do. And so most of what we have are end-to-end tests, where we're saying, how does it work when an actual user comes in and they click around in this form? How does the JavaScript interact with our PHP that's generating the HTML, and how does all this work? So in reality, we find that we tend to write way more end-to-end tests and leave out the integration tests. So the integration tests are not bootstrapping the entire system. You just want to make sure these two modules work together. Now, if you're doing Drupal module development, I find I tend to write way more integration tests because we don't want to bootstrap all of Drupal. We just want to make sure some of these modules and pieces work together. But on a client site, it tends to be more end-to-end tests. So end-to-end tests are essentially running the entire project. Downside is it's very expensive time-wise because you're bootstrapping your entire project. You're actually firing up in a browser or a headless browser, something along those lines, and you're running it as though it's a real person clicking around. And it's great because you find out where these problems are that you would normally have to go through and click around on your site. I remember years ago writing some sort of software update and literally going into sites and clicking from page to page, making sure I didn't break stuff. And that's fine when you've got a 4-page site, but when you're doing, well, I would assume what most of us are doing is larger sites, it's just not a reality. So this is where your end-to-end tests come into play. In Drupal, you're probably doing Behat tests. Behat tests are written in PHP, and it's a quick way to get up and running. Now in Drupal core, we have Nightwatch, and if you're doing JavaScript, you can do Nightwatch. There's sort of a new breed of testing frameworks coming out now, though. Any of the older end-to-end frameworks like Behat, they are going to require Selenium. And if you've ever set up all this stuff, sometimes it works, and then like a month later, suddenly stuff isn't working because your Chrome driver is out of date, and you're going, what happened? And it's just, it's complicated. It's just complicated to get set up. It's complicated to get running. And the great thing is at some point, developers being lazy, we said, hey, let's make this just work and not have to debug all this stuff all the time. So there have been some new things coming out. The one I want to talk about is Cypress. So Cypress is actually a JavaScript framework. And if you're doing Drupal, truthfully, probably stick with Behat for now because Behat has a lot of integration with PHP. So for example, when you're testing whether a node got created, once the test is over, it'll delete that node for you. Whereas things with Cypress, even though it'll do the same sort of things, it doesn't have a lot of the stuff that people have already built for Drupal. But on a whole, Cypress is wonderful. The first time I used it, I went, oh my gosh, this is what testing should be like. So essentially, it runs in the browser. It doesn't use Selenium. It actually runs inside the browser, and Cypress, I don't know, let me rephrase that. So normally it would be something like where it would run in Node.js, and there'd be little API calls to the browser to render things, but Cypress actually runs in the browser. So when you're running your test framework, what you're going to see is on the left side, all of your tests, and on the right side is going to be your site actually running. So the advantage of this is you have time travel, which means once the tests are done, you can go through and click through every stage of how that test rendered and behaved and go back and see where things happen. So when an error happens, you can actually go back and see, here's what it looked like. As well, it'll record videos, and you can have it recording videos of how all of this happened. It also means because it's running in Chrome, by the way, this is one downside. Currently, it only works in Chrome. They're working on allowing it to work in other browsers. But again, I would say the majority of your testing, if it's working in Chrome, great. And if you have some outliers, then you could use Nightwatch or something for those little outliers in Firefox or whatever. But this downside, they're working on that. But Chrome, I think most of us are spending most of our time with that. You can as well mock API calls. So if you are, say, querying Drupal's JSON API or some other API, you can actually mock all those calls while you're doing your tests, if you're not wanting to hit a production server and whatnot. So a lot of built-in, you know, great little nice to haves, as well as automatic waits and reloads. So if you've used Nightwatch, for example, Nightwatch is now in Drupal core. You have to tell it, you know, wait so many seconds in case this element hasn't shown up yet. And the first time I started using Nightwatch, it you know, kind of bit me because I didn't realize I needed to put in these wait times myself. And so I had tests that were failing because a block hadn't shown up yet and I couldn't figure out. Anyway, Cypress does all that automatically. As well as it reloads. If a test fails, it automatically starts trying again. And so here we can see on the left side, if you can see there, it's showing on a before each, visit this URL, and then test that the header site name class is sitting on this element. When you're, oh yeah, there we go. And then when you're actually writing these tests, if you're wanting to know, well, how do I find the thing that I need to query? So I need to know where that header element is. There's actually a little selector. So you can click this little target button, I guess, and it will actually allow you to pick anywhere on the website, point at anything on the website, and it'll automatically not just create the CSS selector or the DOM selector, but it'll actually create all of your JavaScript code to get that thing as well. So, I mean, it's not hard to write that yourself or to figure it out, but it's a really nice convenience, especially if you're new and trying to get up and running really fast. The other advantage is because it's Chrome, I think I mentioned this, you can use Chrome DevTools. So all of your normal debugging tools, all your normal JavaScript debugging tools, they're all here. So it's not like it's some other thing that you're having to render and hope you can see this. It's all right there in Chrome. So if you want to, you can actually go in and change some of your HTML and all that sort of stuff. So where did this come into play for us? The reason we got into this initially, we have a pattern lab instance, which is just a style library. And it's all just straight HTML, CSS, and JavaScript. This then, all these styles get pulled into our Drupal site and any other site. Our pattern lab is framework agnostic. You know, WordPress can use it, all that sort of stuff. And in this, we had I imagine what happens to you guys a lot, or at least did once upon a time. You change one piece of code and you think you're good, and something somewhere completely unrelated broke. And it's not very often we run into issues like that. Thankfully, you know, a lot of development's practices has fixed those sorts of things. But what happened was we had a little multi-select drop-down, and we changed some little piece of JavaScript somewhere else, and it broke that little drop-down. And we had no idea. And we actually pushed this code to production, and suddenly we've got users going, hey, why is this thing broken? And we're going, I don't know, it shouldn't be broken. But the fact is we had no unit test for this, and at no point did any of us go through and click through every little component that we'd ever made for our websites. So we realized, even though we've got all these Behat tests for all these other things, we've got all these unit tests, we really don't have any tests for our pattern library of just our normal CSS and JavaScript. So this is where we implement this, and I have a little demo of it running. This is Cypress running right now. So any of our developers can do their npm install, then do npm run, or run EDE, click all run specs, or you can run them individually, and now it's just going to automatically start ripping through every one of our tests And if you have seizures or something, it's going to be flashing, just FYI. And so I know it kind of doesn't look like much, but it's literally going through every single one of our components, at least our components that do something. Have a lot of components, they don't do anything. They just look like something. So it's testing out every single piece of functionality on our entire pattern lab, and it's done. So it took 25 seconds to run all that, which is the other thing. Pattern lab, Cypress is actually really fast as far as end-to-end test frameworks go. It's very fast. Okay, so that helped our functionality in our pattern lab. What happens though when you have visual problems? So let's say some CSS is now accidentally rendering something as a red button when it should be a blue button. Or you just have images that aren't showing up, right? So this is where visual regression tests come in. This is, it's a bit of a dark art. Visual regression tests are great, but they're also a little complicated. Part of the reason for that is because what you're doing is testing and comparing two screenshots. The problem is sometimes these screenshots should actually be different. For example, you have new content. So if you're doing a screenshot, you're comparing the new updates to your website to the old website, and it turns out there's some piece of content, that test is going to fail because it's going to say, hey, something looks different. But it does have its place. So one that we use is called BackstopJS, and it does just that, compares and references, or compares a reference screenshot with a new screenshot. So we actually use this for our main site farm platform. So we have our site farm platform, which is basically all of our campus sites. We have several hundred sites running in this, and we allow them to sub-theme. So they can change their, the code for CSS and things like that. And we have to be careful because if we change the base theme, let's say we remove a class that they were relying on, and they're trying to theme a CSS class that no longer exists, their site's going to look bad or break or something's not going to be right. So this is where the visual regression tests come into play. They can actually see the reference. They can see the test, which is the new stuff. They can see the difference between them. So it kind of does this pink thing. And they do a little scrubber and go back and forth to see what actually changed. So on something like this, they may see that, oh, well, the article changed. I don't care about that. So they may say, hey, don't worry about this. There's no problems. The interface is kind of cool. It basically creates a static site, and you can see there's 58 tests that passed, 2 that failed. On the left is the reference test, reference screenshot. The right is the test. And so what we're doing is before we push out our code to live, we will take screenshots of all of the live sites within our kind of a select number of people that said, yes, we want to have our sites in the test. So give us a screenshot of all of our sites now. Then we load in our code on the test server, do a screenshot of all those sites again, and let's see what's different. So now our clients can go look and see how everything looks. All right.
Cool. So getting back to our little diagram there. So we've done all these tests, and so the pull request and kind of a lot of these tests are mostly done on either your local development environment, because you've got to run them locally, make sure that things are working, or running through those CI tools, CircleCI or Provo or whatever. I should say, and running on those. These tests can be run in your browser, like you were showing, but they can also be run just automated through those tools. So now we've gone through and we've tested everything, and we've merged the pull request. We're happy with the new code. So now it's time that we get it onto the staging server. And a lot of people, they called this test. Remember, there's dev, test, and live. So a lot of places you'll find this called the test server, but I don't know. I don't think that's the best name for it. I like staging better because by the time it's here, like your testing is probably pretty much done. I think the automated testing is done. The staging server is where we do that BackstopJS visual regression. So I guess there's some testing going on there. Anyway, I like the word staging. So what you got to be able to do now is you got to be able to get a selection of your stuff from live, your content from live, and you're going to stick it onto the test server or the staging server. See, even I say it. And then you're going to kind of simulate your rollout, right? And if you have a lot of sites, like we have hundreds and hundreds of sites, you probably don't need to do it across all of them. But like Mark said, we have a list of maybe about 20 sites that we bring over. And so having a tool to be able to create and deploy this staging server is super helpful. So like this is Site Factory, and so Site Factory lets us create the staging server on either the dev or the test environment. You can select which one, and then you just choose which sites you want to bring over, because again, there's no reason to bring over all 800 sites. Yes, John? Yeah. So we are doing this manually through the web interface. There is an API that can be done. There's also an ACSF tools command line tool that was written by someone at Acquia. I have never successfully gotten that working, unfortunately. Yeah, I even met the guy and talked to him, and I still couldn't do it. So, so this is what we're doing manually. Since it's the same 20 sites every time, I'd love to be able to just do the API, but this is one of the things that, you know, I just haven't gotten around to yet, right? No, but you're right. But this is a good example of a lot of, you know, selecting these through the UI. Sure, it takes me a minute or two, but imagine how long it would take to actually manually copy databases and import them onto a staging environment, or copy the code and, you know, trying to set up the staging environment. So this is what I mean by you're going to end up doing some things manually at some point, but I was able to, we were able to pay Acquia loads of money to streamline this process for us, so that I don't have to spend, you know, 3 hours, or I don't have to get one of our sysadmins to spend 3 hours setting up a staging environment. I can do this in a minute or two and then push go, and then it takes like 20 minutes to do it itself, but I don't have to actually do it. And so, you know, I can be platform agnostic too. This is Pantheon. It does a similar thing, one site at a time, but it's a, you know, all the checkboxes there. Pull files and database from the live environment, clear caches, run update.php. It's going to do all that stuff. It's going to deploy the code to the test environment, what they call test, or staging if you want to call it that. Pull the content from the live environment, simulate your rollout. So this is you know, this is sort of that last step. You make sure everything works together. So certainly, if you don't want to pay Acquia or Pantheon loads of money, you could script all that yourself. You know, just don't do it manually, but find some way of being able to run a script to copy databases into the right place and get all that set up. You could certainly do that yourself. Takes time, but you know. And then that last step, of course, deploying to production. You know, when we're running, we have over 800 sites on Site Factory now, and only about 400 are live. But really, if you're deploying, you have to deploy against all of them, whether they're live or not. It doesn't really matter to me. They all need to be updated. They all need to be patched. And so Site Factory has a nice way of being able to run your code update, and then it runs update.php as it goes through all the different sites. And for us, it takes about 3 hours to go through all sites. Unfortunately, it's sort of slow. I'd like to see that sped up, but at least I don't have to do it. You know, we deploy it in the evening at some point, and I just stay up and bring up my phone every now and then. Is it still going? Any errors? All right, we're good. You know, I don't have to sit there and log into each site and run update.php or even Drush. Again, you can script this using Drush or whatever, but you know, that takes time to figure out, and then, you know, if it takes a long time, you may end up with sites that are old code or new code, old database. If it hasn't run up to PHP yet, Site Factory makes that easy. So and it keeps sites up. So during a normal deployment, we have 0 downtime, and the sites continue to run and they get updated. Yeah.
Okay, so you have 800 sites, and you deploy, which sometimes runs update.php on that,
Mm-hmm.
and it's pretty fast, 3 hours, and you use the site factory to keep up the site while the new version of the site is being built.
So there's a little black magic there that I don't understand because I haven't had Acquia explain it to me. Maybe, John, if you know the correct answer to this. But the way I understand it is that it makes a clone of the environment with all, it's a multi-site, so it's one code base, right? It makes a clone of that onto an update server, updates, and then moves the DNS over to the update server. And then it runs the update, it updates the code on the live server, and then 3 by 3 pulls sites over. And so it takes the database, brings it over, run update.php, and then switch the DNS back to it. So it does switch the sites down into maintenance mode temporarily with Varnish. We never notice. But I can watch New Relic, and I can watch, lots of traffic, nothing, because New Relic is looking at the live server. And the nothing doesn't mean there's no traffic. It means that it's out on the other server. And then I see it slowly climb over 3 hours as sites are brought back over. Is that your understanding of it? Okay. One more, sure. No, that's fine.
Okay, so if it does groups of sites at a time, they're not all in maintenance mode at once.
No. The site continues to be up, not in maintenance mode on the update server, until it gets copied. So I don't know when it goes into maintenance mode, but it gets copied over, run to update.php. So while update.php is running, it's in maintenance mode. Mostly so that someone doesn't go in and try to add a new node or something like that while it's trying to be updated.
There's a task queue, right?
Yeah.
The task queue for 3 or 4 sites at a time. So if you've got 800, you start to feed them into that hopper, right? So the first 4 go into that task queue, and they get put into maintenance mode. Their code gets cut over to the new code base. Update.php gets run, and they get pulled out of maintenance mode, and then their live DNS is playing to that. And then as everything shuffles through that task queue, you go from 800 that need to be updated to 800 that have.
Yep.
Yeah, and they have follow-up questions for later.
Yeah, call Acquia, because they know how this all works, maybe. Yeah, we know how it works pretty well. And again, you could try to script that, right? Set up a whole, update environment, but, generally, if you're running any sort of size of a multi-site, probably what's happening is, you update your code and you hope the update isn't so bad that it breaks your site before you get a chance to run update.php across all of your sites, which might take you, I don't know, an hour, I don't know how many sites, right? So it might take a long time. Or you can put them all in maintenance mode, but now you have a bunch of sites in maintenance mode for an hour, and that's worse, right? Well, I don't know about worse, but it's not awesome either. Again, Pantheon has their tools as well, right? Where it'll deploy the code, it'll run update.php and clear caches, and there's APIs, Pantheon has their Terminus command line tool that you can script a lot of this to, so that you don't have to actually click buttons in an interface. So there we are. I think we covered a lot of those things. Is there any questions about any, and then, well, we have questions. So let's just leave this up for a second. Do we have any questions about any of these processes here? I think we're good, yeah.
I'm wondering, are you using a build repo and an artifact repo type of model? Where does that fit into your?
Sure, the question was, do we have a build repo and an artifact repo? And so the answer is, yes, of course, but we don't manage them really. Like we manage our build, not artifact. We manage our development repo that does not contain any of the artifacts, right? So that's the one that's in Bitbucket. That's the one that we do the pull requests on that, and then when it goes into the CI tools, that's where the build happens. And then because of your composer.lock, you can be relatively confident that what gets built there is going to be built when it goes into production. So that's what's built, and then it's run all the tests, and then all that's destroyed.
And then the artifact gets pushed to the Acquia.
Give me a second. So what ends up happening for the deployment, so here's sort of, actually, it's more like this step here before the staging. And so we use, I love these names, Acquia pipelines, not Bitbucket pipelines, Acquia pipelines. And so that's the tool that we push the unbuilt code to the Acquia repo, and then run Acquia pipelines, and it's really only like 3 steps in the YAML file, 3 script steps, basically just to do a composer install. And then Acquia's pipelines tool understands that when you do the install, what it does in the background is it commits the entire code base to a new branch called pipelines-build- the name of my branch. So the build of the actual deployment is in Acquia, and I can check that out if I want to look at something and see what's changed, but we don't maintain that like in our own repo or try to push it directly to Acquia. We push our unbuilt code to Acquia and then run the build using their tool there. And that's something that, yes, I do on the command line. And certainly that could be something that we put, say, into whenever we merge to master, it automatically runs that build and pushes that code up to Acquia and runs the build onto Acquia. And that's a step that we have manual now. And yes, that's something where we could add efficiency that way as well. I like the idea of doing things manually until you get sick of it, and then you write the code to make it faster. And that's one of those things that's on my list, though, is certainly to just make that happen through a commit. All right. Any more questions? Yes. Yeah, I haven't used it myself. Do you know about the GitLab CI?
It's all integrated with GitLab. So you, like many others, you write a YAML file. You can add a Docker image, set up a bunch of steps, and it works kind of the same way. But it is nice because it's all integrated. You can have things like, for example, they call them merge requests. When you are ready to merge, you can say automatically merge this once my test pass. So there's a lot of kind of cool integrations like that. But honestly, it's kind of like the rest of them. Yeah.
Something also super cool about GitLab's automation is that you have the GitLab server that runs GitLab itself, but then the automation servers, you can set up as many of them as you want wherever you want. And so generally the more powerful your server is, the faster the tests run. And so you can just go get an AWS server or a Linode or wherever, and then you can hook up GitLab into just like any arbitrary server wherever you have extra power running. So it's super awesome that it's like it can just hook into like wherever you happen to have an extra server, you can just turn that into a test server. You just have to install one service on that test server, and then it needs SSH access to a Git repo, and then HTTPS access to communicate back and forth, and it's pretty fantastic.
Yeah, cool.
GitLab does so much.
Cool. Thank you very much, everybody.